Good morning, chemistry students. Today we're going to be talking about balancing equations, but this time we're going to be writing our equations from words to begin with and then balancing those equations. And this is a little bit challenging because it draws on some previous information. So it draws heavily on the nomenclature unit, and there's some other stuff from last semester even that you need to remember. So first thing you need to remember is that ionic compounds have to balance their charges. So if you see an ionic compound that is one that starts with a metal, you know that you have to write out the two charges of the two ions and then balance the charges to write the formula. In a molecular compound, that is one that starts with a nonmetal, of course, the names tell you the formula. If you had an acid, it starts with H+, and then you balance the charges from there. And then the thing from last semester that you need to remember is the diatomic elements. Diatomic elements are the ones that end in gen or ene, so hydrogen or fluorine. Those elements are written with the subscript 2 because they are diatomic. They always come in pairs. So let's do a little practice. So we have this reaction that we're going to write out and balance. And the reaction says sodium chloride and fluorine gas react to form sodium fluoride and chlorine gas. So to write out sodium chloride, we have to decide, is this an ionic compound or something else? And sodium, of course, is a metal, so it is ionic. So we need to write the charges. So we're going to write Na+1. That's the charge on the sodium ion. Of course, we know that by looking on the periodic table to see the charges, the charge trend that we remember from before. And Cl-1, chloride. And then we're going to put those together. And those cancel each other out nicely for the formula NaCl. And then the word and in our word equation is going to be a plus sign. And then we have fluorine gas. We don't just write F, we have to write F2 because fluorine, because it ends in ene, is diatomic. Sometimes kids will think that gases are all diatomic, and that is not true. Many gases are not diatomic, so you can't assume that that's why. The reason that fluorine has the little subscript 2 is because it ends in ene. So if you see the word ene written on the question, then you have to add the 2. Or gen also. And then it says they react to form, so that's an arrow, sodium fluoride. Sodium fluoride is going to be an ionic compound again, starting with a metal. Sodium's charge is Na+1. Fluoride's charge is F-1. So these two will go together to make NaF. And then chlorine gas. Chlorine gas is Cl2. And there we go. Notice sodium fluoride. Yes, it comes from fluorine, and yes, fluorine is diatomic, but that means that if fluorine atoms are not bonded to something else, then they'll have a subscript 2, like we have here. When they are bonded to something else, they may or may not have a subscript of any sort. Since we had a +1 and a -1, we get NaF here. Okay, so now we have our reaction. Now it's time to balance it. So again, to balance an equation, the first thing you want to do is draw a line at the arrow. And then you're going to write each of the elements and how many atoms we have of each one on either side of the arrow. So in the reactant side, we have 1 sodium, 1 chlorine, and 2 fluorine atoms. And on the right, we're going to copy that same list in the same order, NaClF. Sodium is 1 here, chlorine is 2 here, and fluorine is going to be 1 here because there's only 1 fluorine, 2 chlorines, 1 sodium. So is this reaction balanced? No, it is not. Sodium is balanced, chlorine is not, and fluorine is not. So there is a rule that says that if you have hydrogen or oxygen, you should do those last. We don't have either of those, so it doesn't matter which one we want to fix. Let's fix the chlorine first. So we have 2 on the right. We need more chlorine on the left. And the only way we can do that is to put a coefficient here. You cannot add a subscript, just a coefficient here that's going to multiply through this compound. So I'll put a 2 there, which changes both of those elements, sodium and chlorine. It changes sodium to 2, which we really didn't want to change, but we have to. And it changes chlorine also to 2. So that's not ideal that we messed up our sodium, but that's what you have to do. So now we're going to, so this is where we were. We put a 2 here, we fixed those 2. And we said the next thing we're going to try to fix then is fluorine. And to fix the fluorine problem, we have to put a 2 here. And that's going to change the sodium and the fluorine. And the sodium is now going to be 2, which is good because that balances what we messed up over there. And this fluorine is also going to be multiplying through and giving us a 2. 2 sodium, 2 chlorine, 2 fluorine on both sides. So we are good to go. This equation is now balanced. Here's another similar question. We have lithium hydroxide and sulfuric acid, H2SO4, react to form lithium sulfate and water. Now, I wrote in the formula of sulfuric acid, even though you probably already know how to figure out what it is, because for Gen Chem, we decided we're not going to make you memorize the ternary acids, how to write the names for them. So we'll be a little bit helpful to you with that. So lithium hydroxide. Lithium, you look it up on a periodic table and you find it is a metal. So lithium is a metal, so this is ionic. We have to balance the charge. Lithium is Li+1. Hydroxide is a polyatomic ion. Hydroxide is OH -1. You look it up on your polyatomic ion sheet to know that. So those two, a +1 and a -1, are going to go together in a 1-to-1 ratio. So LiOH is our formula for that. And they're going to react with, the and sign is going to be the plus sign here. The and word is a plus sign. They're going to react with H2SO4, so that part's easy. The react to form or yield is the arrow. And then that's going to make lithium sulfate. Now, we know that lithium is a metal, which means this will be ionic. Li is +1. Sulfate is a polyatomic ion. You got to look it up on your polyatomic ion sheet. Sulfate is SO4 -2. So when we put that formula together, we're going to get Li2SO4. And the last thing it says is water. So water is H2O. So this equation is not balanced. Now we're ready to go ahead and balance it. So I just copied that equation over. So to balance our equation, draw a line at the arrow and write down each of the elements on each side in the same order each time so that you can figure out how many atoms of each we currently have. So lithium, we have 1. Oxygen, we have 1 in this molecule and 4 in this molecule. And the plus sign in between them tells us we need to add those two. So 1 + 4 = 5. Hydrogen is going to be 3, 1 here and 2 here. And sulfur, just 1. And then on the right-hand side of the arrow, on the product side, we're going to have lithium is 2. I'm going to do them in the same order. Oxygen is 4 + 1, that's 5. That's good, that's balanced. Hydrogen is 2, and sulfur is 1. Now, there is a very important rule that says solve hydrogen and oxygen last. And if you have both hydrogen and oxygen, you should solve oxygen very last. And I'll show you why. So looking at what we've got lithium unbalanced, oxygen is okay, hydrogen is unbalanced, and sulfur is okay. So we'll start with lithium because we don't want to start with hydrogen because hydrogen is often a problem. So to fix the lithium problem, we're going to go up here, and put a 2. And this multiplies through to everything in this molecule, but not to the rest. So lithium is now going to be 2. Oxygen is going to be 2 here plus 4 here. And that's 6. Lots of students will take this number that was here, this 5, and double it and say it's 10. But putting a 2 here means we get 2 lithium hydroxide molecules, not 2 of the whole left side of the equation. We didn't change the number of oxygen atoms here with this 2. It only applies to this molecule right behind it. And unfortunately, this screws up our oxygen, which we didn't really want to do, but that's okay. And it changes our hydrogen now to 2 hydrogen here plus 2 here, so that's 4. And our sulfur doesn't change. So let's reevaluate. Lithium. Okay, so we were here when I got cut off. Oops, nope, too far. I think we were here. Well, let's just go from here. How about that? So we put a 2 in front of LiOH, which gave us 2 lithium, and it changed our oxygen to 2 oxygen here and 4 oxygen here. That's 6. And it also changed our hydrogen to 2 hydrogen here and 2 hydrogen here, and that's 4. And we didn't really want to change the oxygen because it was already balanced, but unfortunately, this is what we have to do. There's really no other option. Okay, so now we have lithium is balanced, oxygen is not, hydrogen is not, and sulfur is. So we have oxygen and hydrogen left to do, and the rule says do oxygen very last. So we're going to do oxygen very last. We'll do hydrogen next. We want hydrogen to be 4, so we're going to put a 2 here, and that's going to give us 4 hydrogen. And it's going to change our oxygen as well. It's going to give us 2 oxygen for our 2 water molecules. And we have 4 oxygen over here in our lithium sulfate. So 2 plus 4 is 6. And now our equation is balanced. Lithium is 2, oxygen is 6, there's 4 hydrogens, and there's 1 sulfur on each side of the equation. So that's how you balance equations from words. First, you use the words and your periodic table and your polyatomic ion sheet to write out each of the equations in symbols. Then you use that to balance the equation. It takes a little bit of effort, a little bit longer than what we did with our balancing last time. All right, if you have any questions, you know where to find me. Talk to you soon.